Lemur, Harmonizing Natural Language and Code for Language Agents. We introduce Lemur and Lemur Chat, openly accessible language models optimized for both natural language and coding capabilities to serve as the backbone of versatile language agents. The evolution from language chat models to functional language agents demands that models not only master human interaction, reasoning, and planning, but also ensure grounding in the relevant environments. This calls for a harmonious blend of language and coding capabilities in the models. Lemur and Lemur Chat are proposed to address this necessity, demonstrating balanced proficiencies in both domains, unlike existing open-source models that tend to specialize in either. Through meticulous pre-training using a code-intensive corpus and instruction fine-tuning on text and code data, our models achieve state-of-the-art average performance across diverse text and coding benchmarks among open-source models. Comprehensive experiments demonstrate Lemur's superiority over existing open-source models and its proficiency across various agent tasks involving human communication, tool usage, and interaction under fully and partially observable environments. The harmonization between natural and programming languages enables Lemur Chat to significantly narrow the gap with proprietary models on agent abilities, providing key insights into developing advanced open-source agents adept at reasoning, planning, and operating seamlessly across environments. The project's website can be found at Project's website. Prometheus, Inducing fine-grained evaluation capability in language models. Recently, using a powerful proprietary large language model, LLM, for example GPT-4, as an evaluator for long-form responses has become the de facto standard. However, for practitioners with large-scale evaluation tasks and custom criteria in consideration, for example, child readability, using proprietary LLMs as an evaluator is unreliable due to the closed-source nature, uncontrolled versioning, and prohibitive costs. In this work, we propose Prometheus, a fully open-source LLM that is on par with GPT-4's evaluation capabilities when the appropriate reference materials, reference answer, score rubric, are accompanied. We first construct the feedback collection, a new dataset that consists of 1K fine-grained score rubrics, 20K instructions, and 100K responses and language feedback generated by GPT-4. Using the feedback collection, we train Prometheus, a 13B evaluator LLM that can assess any given long-form text based on customized score rubric provided by the user. Experimental results show that Prometheus scores a Pearson correlation of 0.897 with human evaluators when evaluating with 45 customized score rubrics, which is on par with GPT-4, 0.882, and greatly outperforms ChatGPT, 0.392. Furthermore, measuring correlation with GPT-4 with 1222 customized score rubrics across 4 benchmarks, MT Bench, Vicuna Bench, Feedback Bench, Flask Eval, shows similar trends, bolstering Prometheus's capability as an evaluator LLM. Lastly, Prometheus achieves the highest accuracy on 2 human preference benchmarks, HHH alignment and AMP-MT bench human judgment, compared to open-sourced reward models explicitly trained on human preference datasets, highlighting its potential as an universal reward model. We open-source our code, dataset, and model at Project's website. Octopus, Embodied Vision Language Programmer from Environmental Feedback. Large vision language models, VLMs, have achieved substantial progress in multimodal perception and reasoning. Furthermore, when seamlessly integrated into an embodied agent, it signifies a crucial stride towards the creation of autonomous and context-aware systems capable of formulating plans and executing commands with precision. In this paper, we introduce Octopus, a novel VLM designed to proficiently decipher an agent's vision and textual task objectives, and to formulate intricate action sequences and generate executable code. Our design allows the agent to adeptly handle a wide spectrum of tasks, ranging from mundane daily chores in simulators to sophisticated interactions in complex video games. Octopus is trained by leveraging GPT-4 to control an explorative agent to generate training data, that is, action blueprints, and the corresponding executable code within our experimental environment called Octoverse. We also collect the feedback that allows the enhanced training scheme of reinforcement learning with environmental feedback, RLEF. Through a series of experiments, we illuminate Octopus's functionality and present compelling results, and the proposed RLEF turns out to refine the agent's decision-making. By open-sourcing our model architecture, simulator, and dataset, we aspire to ignite further innovation and foster collaborative applications within the broader embodied AI community. Idea 2, IMG. Iterative self-refinement with GPT-4v, ision, for automatic image design and generation. We introduce Idea to Image, a system that enables multimodal iterative self-refinement with GPT-4v, ision, for automatic image design and generation. Humans can quickly identify the characteristics of different text-to-image, T2I models, via iterative explorations. This enables them to efficiently convert their high-level generation ideas into effective T2I prompts that can produce good images. We investigate if systems based on large multimodal models, LMMs, can develop analogous multimodal self-refinement abilities that enable exploring unknown models or environments via self-refining tries. Idea 2 IMG cyclically generates revised T2 I prompts to synthesize draft images and provides directional feedback for prompt revision, both conditioned on its memory of the probed T2I model's characteristics. The iterative self-refinement brings Idea 2 IMG various advantages over vanilla T2I models. Notably, Idea 2 IMG can process input ideas with interleaved image-text sequences, follow ideas with design instructions, and generate images of better semantic and visual qualities. The user preference study validates the efficacy of multimodal iterative self-refinement on automatic image design and generation. EIPE-text, Evaluation-Guided Iterative Plan, Extraction for Long-Form Narrative Text Generation. Plan and write is a common hierarchical approach in long-form narrative text generation, which first creates a plan to guide the narrative writing. Following this approach, several studies rely on simply prompting large language models for planning, which often yields suboptimal results. In this paper, we propose a new framework called Evaluation-Guided Iterative Plan Extraction for long-form narrative text generation, EIPE-text, which extracts plans from the corpus of narratives and utilizes the extracted plans to construct a better planner. EIPE-text has 3 stages: plan extraction, learning, and inference. In the plan extraction stage, it iteratively extracts and improves plans from the narrative corpus and constructs a plan corpus. We propose a question-answer (QA) based evaluation mechanism to automatically evaluate the plans and generate detailed plan refinement instructions to guide the iterative improvement. In the learning stage, we build a better planner by fine-tuning with the plan corpus or in-context learning with examples in the plan corpus. Finally, we leverage a hierarchical approach to generate long-form narratives. We evaluate the effectiveness of EIPE-text in the domains of novels and storytelling. Both GPT-4-based evaluations and human evaluations demonstrate that our method can generate more coherent and relevant long-form narratives. Our code will be released in the future. LangNav, language as a perceptual representation for navigation. We explore the use of language as a perceptual representation for vision and language navigation. Our approach uses off-the-shelf vision systems for image captioning and object detection to convert an agent's egocentric panoramic view at each time step into natural language descriptions. We then fine-tune a pre-trained language model to select an action based on the current view and the trajectory history that would best fulfill the navigation instructions. In contrast to the standard setup, which adapts a pre-trained language model to work directly with continuous visual features from pre-trained vision models, our approach instead uses discrete language as the perceptual representation. We explore 2 use cases of our language-based navigation, LangNav approach, on the R2R vision and language navigation benchmark, generating synthetic trajectories from a prompted large language model, GPT-4, with which to fine-tune a smaller language model, and sim-to-real transfer, where we transfer a policy learned on a simulated environment, Alfred, to a real-world environment, R2R. Our approach is found to improve upon strong baselines that rely on visual features in settings where only a few gold trajectories, 10, 100, are available, demonstrating the potential of using language as a perceptual representation for navigation tasks.